Moving over to receive now with the Harvard 400M, a radio that uses the Hong Kong CB240 chassis. And the first thing we need to do on receive, and it is working this set on receive, first thing we need to do is to go for the first alignment point, and that is, and I'll just look at my sheet here, transformer 5. So that's next to the relay there. I'm using a synad meter. There we go, that's peaked. I'll just back off the attenuator and go for the second receive one, transformer 6. And then I'll just go back on the first one, because they are interactive. Now, have we got any further receive points on these radios? No, not that I can see on my crib sheet here. So now we'll move over to the detector. And I'll work out how that's done, because I can't even spot it on my sheet, and we'll pause the video while I do that. Okay, checking with the circuit and the service manual, there isn't a detector, it's a simplified type of circuit, and the output of the MC335 second 7 goes through a ceramic filter, and that's it. So we can't set that. I'm setting now the radio to 100 microvolts as if we were setting up that, just to do the S meter. Let's see what that's reading. Well, it's reading just over the 7, so we'll just put that nearer towards being 7, between 7 and 30. And the S meter adjustment is VR7, which is just there. Again, it's dirty, the control, so we'll just clean that with the cleaner. Waggle that around a bit. And there we have S9 set. Next thing we're going to do is set the squelch. So we're going to turn the signal generator off, set the squelch to threshold, switch the generator back on, and the squelch comes in. Just. It actually comes in, let's have a look, at just over 0.4 of a microvolt. So that's okay. Now we'll turn the squelch to full. And unfortunately it comes in at 3 microvolts. Now this is where these sets are a bit of a letdown, and that's on the squelch department. We'll see if we can improve on that. It's variable resistor 4, and variable resistor 4 is that one there. Now all these other controls have been dirty, so we'll just clean that. We'll give it a waggle round. That is maximum, so just see how that performs. So we'll start again with the first test. Switch the generator off. And set threshold. Now we'll switch the generator back on. And it comes in at 0.3 of a microvolt just. So we'll just see when that's reliable. 0.5. Now we'll set the squelch to full. No, that's no good at all, it never comes in. So what we'll now have to do is just back that off a fraction. We'll start those tests all over again. So generator off. Set squelch. Generator on. Set squelch to full. adjust the attenuator on the signal generator, and it never comes in. So once again we'll adjust the squelch. Isn't this laborious? Then we'll start again. Generator off, squelch to threshold, generator on, it comes in. Squelch to full, adjust the attenuator until that comes in. It never comes in. Adjust the preset, start again. Threshold, that comes in okay. Squelch to full, and it never comes in. Let's adjust the preset again. Generator off, set squelch threshold, generator on, set squelch to full, and once again it never comes in. So again we adjust it. So this is the letdown on these sets, I'm afraid. So set the squelch threshold, generator back on, squelch to full, and it comes in at 10 microvolts. Now we'd like it stronger than that, but we've been doing this meticulously and in that laborious way. We've got it to the best setting we possibly can. That's 10 microvolts. So there we have it. That is now set up, and that is as spot on as it's ever going to be. So it's a squelch that lets these down. Where we are in a rural position, that's fine, but if you're in a town, you've got a lot of users, you'd have difficulty squelching out some of the noise with this type of chassis. Now just check that I'll just put our monitor receiver on. We'll just check that that rotor bleep works. It does. Excellent. Right, we'll put that on the air later on today, and hope you've enjoyed looking at the setup procedure on the Harvard 400M.